Hey gang, after watching that first 5.2 video, which was, I don't know, like half-hour long or something, your head might be spinning a little bit. Um, I definitely wanted to do a quick follow-up video, especially considering what your 5.2a homework will actually involve. So, in 5.2a, I believe you were shown the substitution method, where you take a piece of one of the equations and you substitute it in to the other equation, and that allows you to solve for your first variable and yada yada yada. Your homework here for 5.2a is probably going to seem, it's still the substitution method, but it's a simpler kind of example that you'll probably be much more comfortable with and find a whole lot simpler, because it is, I don't know, it seems like inarguable. So I want to do a couple examples here for you. And again, keep in mind, this is still technically the substitution method. So what makes this example, the category of example that it is that look at both of these equations. If you remember from your first video, right, you only needed one of the equations to tell you what x equals or what y equals, right? Do you remember that? You only needed one of them to say x equals this or y equals this. But do you notice how both of these equations tell you what y equals? They are both solved for y. I'll even write that down just to emphasize my point, I guess. So here's what you can do in this situation. You can just set the equations equal to each other. If y equals 2x plus 3, as well as y equals negative x plus 9, you can set the 2x plus 3 equal to negative x plus 9. Essentially setting the equations equal to each other. Now, I don't want to go too deep down this rabbit hole, but I'm just going to say again, what I just did to get this step, that's technically still the substitution method, like subbing in 2x plus 3 into the y in the other equation. That's really all I'll say. But this is technically substitution. Now that you have this, you can solve for x. Okay? By first getting the x's only on one side. So I'm going to move this x to the other side. Again, we've done this kind of solving dozens of times. So this would be 3x along with the plus 3. And now over here you just have the 9. And now you finish this up by getting the x all by itself, right? Divide both sides by 3, and you end up with x equals 2. Right? So x equals 2. But don't forget that you also need to figure out y. So you're just going to take this x equals 2 and plug it into one of these equations. It doesn't matter, but I'm going to pick the first one. So y equals 2x plus 3. Well, now we know that x is 2. Y equals 2x plus 3. Okay, so 2 times 2 is 4, plus 3 is 7. So y equals 7. So my overall solution here is that x equals 2 and y equals 7 at the same time, or 2, 7. One more quick example. Nothing new about this really. Maybe the fraction, I don't know. That could mess with you a little bit. But still, notice that both equations are equal to y. So you can set the equations equal to each other. Now remember, you can only do this when both equations are equal to y. You know, if this equation was equal to y and this equation was something random like 3x minus 7y equals 4, then you couldn't do this specific strategy. But now that you've set the equations equal to each other, now we can go ahead and solve for x. Now, could you add 3x over here and literally add 3x to 1/2 x? Yeah, of course you could. There's all different kinds of ways to approach this. You can leave it as a fraction, and like I said, you could change that to a 0.5x. I mean, it's a clean enough decimal. I mean, maybe you'd rather work with a decimal here, considering it's a clean decimal. You could, look, I'm thinking of all different kinds of stuff. You could literally multiply both sides by 2, literally multiply everything by 2, and that way you wouldn't have any more fractions. I mean, there's all different kinds of stuff you could do. Maybe I'll keep it pretty standard. And what's 1/2 x plus 3x? You know, you could leave it in as a fraction, but I'm going to just say 3.5x, if you don't mind. And now it's time to just keep getting x by itself by doing that. Oop, I forgot the x, almost. And now we would divide both sides by 3.5 to get x all by itself, and you end up with x equals 2. So now I'm just going to plug that into maybe I'll pick this equation this time because it doesn't matter, because I still need to figure out what y is going to equal. So y equals -3x. Well, now we know that x is actually a 2 in disguise. -6 plus 4, -2. So my final answer is 2, -2. So that's how that works. Remember, this was, this is going to be, I think, my biggest priority with teaching you guys this fancy schmancy substitution method, is showing you the specific scenario when you have both equations equal to, say, y, and that in that situation, our substitution method can be pretty much described as setting the equations equal to each other and then solving like you've done hundreds of times.